question about the test. There was a question where they gave you a function and they asked you which was it? Was it like two rational numbers, two?
No, everybody, I'll answer it after the, because everybody's not taking the exam.
Oh, okay. But my,
You have to wait. I can answer it afterwards.
okay.
Given that problem, it says find the domain of that function. How would you go about finding the domain of that function?
Back on the bottom.
Yeah, find out what, find out what will make the bottom zero, the denominator zero, and it can't be that.
Everybody get that? Everybody see how to do that problem? Anybody not know how to do that problem? Given that function, I will ask you two questions about this particular function. And that is, what is the domain and what is the range of that function? What is the domain and what is the range of that function? What is the domain and range of that function?
The domain is all real numbers. All real numbers is the domain.
Very good. The domain is all real numbers. Why can you quickly say that? Well, a couple of reasons. It is not a rational function. It's not in fractional form. There's not a denominator that could possibly be zero. And it's also what? Not under the radical. So that's just a what? That's just a polynomial equation. It's continuous everywhere. So what numbers can't you use? Gosh, you could use all of them. Every possible real number will work. My second question is, what is the range of this function? What is the range? Do you understand the difference between the domain and the range? How many of you know what the difference between the two of them are?
One's the x value, one's the y value?
Yeah, one of them is the domain is determined by what x values will the machine take on. What x values can the equation take on? That's called the domain. Well, the range is what you get back when you do put these numbers in. So what would the range be in this problem? Well, let me ask you this. How would you go about determining the range? once you see it, you're gonna see how easy it is. No? Anybody? Nobody? If you did this, then you would know that what? That's what it looks like, right? How do you know that? How do you know immediately that's what that function looks like?
Because the only point where it touches the x-axis.
Yeah, there's only one point. In other words, if you factored that, it would get what?
X minus 5.
X minus 5. So the two values that make it 0 would be what? Would be a 5 and a 5. You have to name both of them because it's important even though they are the same number. For what reason? Because the solution set is of even multiplicity, which means nothing more than there's an even number of solutions. In other words, 5, there's how many 5s as a solution? There's 2, and 2 is what? Is an even number. So that's just saying they call it an even multiplicity. All it means is there's multiple 5s. And the multiples are even. They're even number of them. If there were 3 5s that made it 0, it'd be of odd multiplicity, which would mean it would go through the graph at what? At 5. The line would actually pass through the graph. It would then be a third power equation. It would be a third power equation. So it means it would go up like this and down like this. So since this was an even power, positive coefficient, you know it's up like this on both sides. And it takes on every single number in the real world. You can choose any number on that real number line and put in there for x. So the domain is all real numbers. But the range is what?
All numbers greater than or equal to 0?
Yeah, in other words, from 0 upward. The lowest number you will find for the y value on that picture is what? Is 0. You can't find another number lower than what? Than 0. How about this particular function? Y is f of x is equal to what? X squared minus 25. That would, you know what? This one does what?
Crosses at 5 and -5.
It does that number. And again, it takes on all real numbers as a domain. You can use every single number in the real number line for x. But if you did, what is the range of this problem right here? What is the range? The range would have to be what? Minus 25 is the lowest number you will find on that picture over there. Y is never smaller than minus 25.
Why? Why isn't it?
Well, because that's the vertex. 0 minus 25 is the vertex. Right? No? Tippy, you see that?
Yeah, I see it,
Now, you sure?
pretty sure.
I didn't like that answer, pretty sure. Did he say, yeah, of course I see that. Any questions about the domain and the range?
So do you just find the range by graphing it?
What now?
Do you find the range by graphing it?
Yeah, most of the time, yes. By graphing the problem. What about the range of this problem? F of x is equal to what? What's the domain? What's the domain? Don't look at that. What's the domain?
All real numbers.
All real numbers. Why is that the domain? Because it's not in what? It's not in fractional form. It is not on the radical. And so, what does it actually look like? It looks like what?
Looks like an S.
Just like that. So the range is what? All real numbers. No, y'all don't see that.
So anything where the exponent is odd, it's gonna be, the range will be all real numbers?
Possibly. It just depends on, you know, if it's quadratic, you know it's not going to be, the range is not going to be all real numbers because there is a vertex somewhere where the y value stops and goes the other way. Does that make any sense at all?
Yeah, I get it now.
What about this function? What is the domain and range of that problem?
All real numbers except 0.
All real numbers is the domain except 0. Okay? How about the range?
All real numbers except 0.
Yeah, because it looks like what? Right? So, could you ever make that equal to 0? No. Minus infinity to plus infinity, but it can't be 0, because you can't make this 0. Does that make sense, everybody? A little? Now, there will be times in which you will do what? You will actually determine and put restrictions on the domain. What would be a good example of putting restrictions on the domain and the range as far as that goes? We've worked problems like this already, so you should be able to come up with an example problem just like that.
Like any inequality?
Where would be a problem that we've worked on in here in which you do what? You impose the range of the domain of the problem itself. But I mean, it's not just because you want to do it, it's because it doesn't make any sense.
Like a profit thing? I forget what they're called.
Well,
Other thing with the
you remember the one where you threw the rock up in the air?
Okay.
Time can't be negative, right? Can time be negative?
Possibly.
can distance be negative? Not really. You cannot add minus 3 feet onto a building. Now, when you're working with these problems and you say that's minus and that's plus, that's only direction. That's only in a direction. If you drew this picture like this, it says, you know, or this, for example. This is what? That's a 500-pound. That's a 500-pound sign. That's being held by what? By 2 cables. Now, when you label this thing, you label that 500-pound sign as being what? Being negative. It is not a negative 500 pounds. It is 500 pounds in the what? In the negative direction. Just as if you say what? That direction is in the negative direction. That is in the positive direction. You cannot put a negative force on that door or that wall or that chair or whatever else. I want to see you put a negative force on it. Anybody? I don't think so. You can only do what? You can say, I can put a force in the negative direction. And you make up the direction. You may say, that's negative, and this is what? This is positive. This is a positive direction. This is what? A negative direction. That's all you can do. And your job is to do what? Is to take problems like this and determine what should be the strength of the cables to hold that 500-pound sign up. And if this happens to be a 20-degree angle, both of them, it becomes fairly easy to calculate, and we won't do that calculation. But a lot of times they make a mistake, and as they did in Atlanta when they were building the Olympic Stadium, what did they do? The lights fell in, and they killed a guy. The only problem that they found in their calculations is somebody took the sine of an angle instead of the cosine of an angle. That is the only mistake made, and that caused them to crumble in and fall and take the man's life. All because somebody didn't do the math correctly. And nobody caught him. Nobody caught the mistake. Everybody kept looking at it, looking at it, looking at it. Never once say it, you know. When the mistakes are made, how many of you would think that you better have a cable that holds 750 pounds to hold that sign up? Both of those cables are going to have around 750 pounds of force on them. You say that one cable is more than what the sign weighs. It doesn't matter. It all depends on what? The what? What angle you put the cable in. You put the cable in at what? 20 degrees? You ever tried to hold yourself up like this? It's a lot easier to hold yourself up like this than it is like this, right? You ever tried to hold yourself up like this? That's why it appears that some of the athletes or the gymnasts really do what? They defy the laws of physics. Because it appears at times that they are what? that are holding themselves up like this. Are they really? Not really. What's happening is because the cables are going out like this, and they are really not like this, but it is still at an angle, but it takes a tremendous, unbelievable amount of strength to do what they do. And they push themselves up over it, so they go past that. There's an infinite amount of force on your arms here. If you try to hold yourself up like this, or if you did this, where you restrict yourself, you see that problem? What have you done in that problem there? You've actually taken the function and done what to it? You've chopped it up. You've chopped it up. And now you have what? You have a force domain and a force range in this problem. What is your domain in this problem?
0 to negative 5. 0 to negative 5.
0 to negative 5 is the domain. What about the range?
0 to 8.
What?
0 to 8.
0 to 8. Anybody got any questions about it? No, I guess so. Well, I guess y'all got this pretty much. Everybody's not paying attention, so I guess you got this. Let's move to something new. No more about the domain and range. That's where you've been given two functions, okay? You've been given two functions now. They could ask you to do something. Okay, look at y'all just do this. Everybody seems to be working on their own problems, so maybe I should just let y'all have them. Everybody. Do this for me. Do that. Do you understand what that's asking you to do?